Alright guys, now it's time. How are these threads used? So let's take a look at how we're going to activate, use, and define this thread concept we've been talking about for the past 2 lessons. First, let me define a package here. Let's have a runner like this. What should we call it? I'm going to define 2 things, like player 1 and player 2. I'm going to define a class, guys. Now, you need to make these classes runnable on a thread. In other words, you need to make the classes you normally use runnable on a thread, that is, on a new thread you will create. There are 2 ways to do this, guys. The first is to do it using the Runnable interface. Let me write it like this, for example. You need to implement the Runnable interface in your class and override the run method inside it. So, you write here the operation you want to perform, the task you want to execute. This is the part of the class that runs on a thread. Remember the runnable part in the thread? In other words, the part that will run when you start the thread. So, this is the part that will be executed on that thread, guys. This is the part that will execute a piece of code. So, what do you want to do here? There is a value. You want to increase or decrease this value. Now, let's do it like this. Let me define something called game here as well. Inside this game, well, it won't be anything too fancy. Public integer. Let's call it score. Let's leave it like this for now. We have a value like this. Inside the game, we have something called score. Now, when creating the second user, first I'll provide the game object. I'll say game like this. Let me make this priority so it's correct. I'm saying public player 2. When creating an object from this, I'm saying, give me the reference of the game object. So, let's do it like this. For example, using that game here. For int I equals 0i less than or equal to 100i plus plus. Here I say this game should be plus plus. Pardon. Let the point score be plus plus. Now what was this second player doing? It increases the score value inside the game object by 1. I moved it to the side like this. This is the first player. I'm also extending the second player. From what? From thread. Guys, look. In the first one, it implements this runnable interface and overwrites the run method. With this thread, you can directly do it, guys. You can use it by extending it. Let's see what's inside the thread. What's in it? What is this thread? Let's see. Has thread implemented anything? Look. Thread has implemented runnable as well. Yeah. So, the run method must have been overwritten inside this. Right. It should be inside here. Otherwise, how else would it be used, right? Of course, there are a lot of parameters inside this. We'll touch on those as their time comes. There are a lot of structures used here. Here too, guys, the run method has been overwritten. So, what are we going to do then, teacher? What do you need in order to create a thread to be able to run a thread? The implementation of the Runnable interface and its run method. If you extend thread here, this class will already be extended from both thread and Runnable. So, it can be run on a thread. Alright, let's write this as well. So then, I'm saying here, game public player 1. Here, I'm saying game. This .game equals game. Now, what am I going to do here? I'm going to say public void run. Look, you can already see here that we've overwritten it. I say int I equals 0, I less than 100, I minus, and then I say this .game.score minus. Let this one be ++. Now, friends, while the second player will increase the score value inside game 1 by 1, the other will decrease it 1 by 1. Now, I want to ask you this. Both players score at the same time, so one scores. What is our first score value? None. What happens if one increases and the other decreases? One increases, one decreases, or one decreases, one increases. Isn't it? So you would expect it to be like this. 0, 1, 0, 1, 0. Or when it's 0, -1, 0, -1, 0. You would expect it to be like this. Right. Normally, if you want to make a class runnable on a thread, what you need to do is either extend thread or implement runnable, friends. This is how it should be used. So, how are we going to run these? How are we going to execute them? To do this, you need to create a new thread and, normally, what do you need to do on a new thread? You need to run it. Let's write it like this. This or that run stays here. Let's get player 1 here. L6 both at the same time. This is player 2, player 1. We also have score information here. Friends, what do you actually do here? Player 1 equals new player 1, isn't it? What does he want from you in this way? He wants a game. Look, what am I doing now? Game. I say game equals new game. Now here, game.score equals. Let's say it's 500. Okay, friends. I gave game here as well. Look, I gave game to player 1. Player 1. Now what do I want this to be? I'm going to do player 1.run for this. I'm going to run this. Then the other one is player 2. Player 2 equals new. This one also wants a game. I'm going to give game to this one as well. Now, you need to pay attention to this here. Before saying run for this one, I ran both of them like this, friends. I gave the game to both of them, these two values. Now, what happens if I do it like this, both of them? Look, it's very important that you understand the basic logic here. Right here. If the reference address of the game is this, if this is the reference address, the value you pass here is the reference address of the game object. This way, both of them access this memory here in the heap area. When you say player1.run for these, or say new thread, where was it? When you say player2.start, or let's just call this one start directly as well. Now, when you say start for both of these like this, this one runs in a separate thread, and so does this one. These two run in different threads. So, our code has its own flow. For example, I'm going to write this here, friends. Out, the application has ended. Now look, I'm running this application. Let's exit like this. Of course, since we didn't print anything to the screen, we couldn't see the result. Let's do it like this. This part here. Let me put parentheses around it. Out. This is player 2. Let's call it P2. Plus. This game.score. Alright. Let's close this one the same way. Out. Let's write player1 this game.score and restart the application. Now, please scroll all the way up. Do you notice this? What does it say here? It says the application has ended. Friends. Well, teacher, didn't these run? Look, this is very, very, very important. It's extremely important. Normally, in Java, code flows from top to bottom, right? This runs, then this, then this, then this, and so on. So, this should have run last. In other words, the last thing printed to the screen should have been this. But look, the thing that was supposed to be printed last was actually printed first. Why? The reason lies exactly here. This is precisely where you need to understand threads. When you start a thread, like when you start new threads here, they break away from the current flow and execute their tasks separately within the CPU. Look, these start sections here are what actually run your processes, the ones you defined with run when you call start. This runs in a separate thread. This one is in a separate thread too. The part where our code flows, this here, friends, is the main thread. Normally, all the code you've written up to now runs in the main thread, flowing from top to bottom. That's why it's perfectly normal for the code to end here, because the code has flowed from top to bottom and finished here. At this point, the main thread has basically finished the coding part. However, these two separate threads connected to the main thread keep running. Look, what happened? P1 has run. See, I started player 1 first, right? I started it. P1 has run. It has run. Look, 499, 499, 500, 499, 500, 501, 2, 3. Look, it increased and decreased. See? Alright, let's go to the end. So, let's see what happened when these operations are completely finished. Let's see what happened in the final result. Actually, you need to check here when everything is completely finished. Yes, so what's the final value? It came out as 501, so why is it 501? Why is it 501 and not 500? Normally, it should have ended at 500. Actually, what I mentioned earlier happened here. In other words, both of them read the same value at the same time. Since one of them intervened with the value afterwards, what was the final output? It became 501. So, player 2 at the same time, both player 1 and player 2 read that value simultaneously. What was the value? Got 500. One of them made it 499. Then the other came. It went from 500 to 501. It was 500. Both them read 500. One decreased, 499. The other 500, 501. Printed it to the screen. 501 became the final value. So here, threads are used and run in this way. Either you run a runnable, or you run it by inheriting the thread like this. So, which one is correct to do? Which one is right to use? Guys, now the whole extend thing, the act of extending. So, doing it by extending a thread is a bit problematic. Why is it problematic? Now, by nature, we inherit in our applications. Guys, I mean, we can do it fully by inheriting. Now, you want to inherit in your own application. You want to use a class by inheriting from it. But you went ahead and inherited from thread. There's no multiple inheritance in Java. So you can't do multiple inheritance, and because of that, if the class you're inheriting from doesn't work with the thread logic, if it doesn't have a thread, and you've already used your single inheritance right with thread, then you can't inherit from the class you actually want to inherit from. That's why, generally, using Runnable by implementing it is a much better approach for us. As a piece of advice, if you want to do asynchronous programming, it's definitely better to use it by implementing Runnable like this, friends. So, the basic idea of creating and using threads is essentially like this. The main logic here is to create a thread and then start that thread, friends. When you start it, let's go to the start. When you start it, what you're actually doing is this. You're actually starting to run the run method here, friends. So, with start, you initiate the process. The runnable method takes run, completes its task, and then terminates. That's how the system works. So, why did we just write start here, but created something like this over there? Friends, what was our goal? To create a new thread. In other words, to abstract it from the main thread and run it in a new thread. What exactly? The run method, the runnable structure. That's why, since the player here extends from thread, it already has a run method inside and has implemented runnable. So, you've already created a thread object here, because it extends from here. That's why you start it. But when your class implements runnable, you need to say new thread to create a new thread. You need to say new thread, give it your runnable class, and then call start. With this start, it actually starts the run method of your runnable method. That's how the system works, friends. Now, in the first part, we've learned how you can run classes on threads and how you can define them.